So today, lesson 26 AA, features of nonlinear graphs. So obviously our focus, once again, is on graphs that are not linear. So let's go ahead and get started. So yesterday I brought in a couple of nonlinear graphs that we had talked about several lessons ago. One with absolute value around a variable, and that led to a V-looking graph. And I asked you where the graph was increasing or decreasing, and so we kind of talked about that we read a graph from left to right. And so this graph, since it is going downhill on the left-hand side of the graph from left to right, that is where it is decreasing. And in interval notation, which we're bringing back again today, would be from negative infinity to 0. And then on the right-hand side of the graph, where it is going uphill from left to right, that is where the graph is increasing, and that would be from 0 to infinity. And then we took a look at another graph that we had worked on several lessons ago, an upside-down parabola, and that graph is increasing from negative infinity to 0 because that's where the graph is going uphill. And then on the right side of that graph where it's going downhill, that is where the graph is decreasing. So it's increasing from negative infinity to 0 and decreasing from 0 to infinity. And neither the previous graph nor this one have any parts on it that are constant. Okay? All right, so this is not in your notes, so just look up here. So we're trying to figure out, there's 4 intervals that are given there, from negative 2 to 1, from 1 to 4, from 4 to 5, from 5 to 7. And we're trying to figure out whether it's increasing or decreasing or constant. And so remember, we read a graph from left to right. So it's like you're looking from here to here, which happens to be the first interval, from negative 2 to 1, and so on. So very quickly, turn to your shoulder partner, talk about each interval and whether the interval is increasing, decreasing, or constant. Go ahead. All right, let's go through each interval. From negative 2 to 1, increasing, decreasing, or constant? It is decreasing because it's going downhill from negative 2 to 1. 1 to 4, which one? Constant, good. It's flat right there. It's not changing, no rate of change, or a 0 rate of change. And then from 4 to 5? Increasing. And then 5 to 7? It's increasing at a different rate, and we kind of saw some of that in the graphs that we were doing yesterday. Okay? So that's just a basic review of what we mean by increasing, decreasing, or constant. So, number 1, we have a graph that sometimes we refer to things like this as piecewise functions because it's made up of several different graphs. I want you to turn to your shoulder partner and come up with all the intervals of increase and decrease. I'll get back to you in about a minute and a half. Go ahead. All right, so let's take a look at number 1. So we can see that the graph is increasing from here to here, and from here to here, and then from here to here. So there's actually 3 different intervals where it is increasing. Now I told you yesterday and the day before that, or the lesson before that, that we were bringing back interval notation and we're also bringing back union notation. Back when we were talking about compounding inequalities, to link different intervals together, we would use the union symbol U, and that's how we type it in MyOpenMath, the letter U, to tie together multiple intervals. So going from left to right, we have the first interval of increase from negative 3 to negative 1. That's from here to here. The next one is from 2 to 5. And then since the last one is also increasing but at a different rate, that's technically a different interval. So when we put all 3 of those together, we have from negative 3 to negative 1, union from 2 to 5, union from 5 to 7. And union is just a way of tying together multiple intervals. Okay? And then decrease, I can see that we are decreasing on this interval right here from -1 to +2. Now remember, we're just reading this graph from left to right. So that interval would be from -1 to +2. Now notice that I did not use any brackets, only parentheses when we're doing intervals of increase and decrease. And that's because at the points where it's changing, we're not actually increasing or decreasing at those points. So what I'm talking about is here and here and here. We're actually changing there, not increasing or decreasing. And so there are no intervals where it's constant. And so you might want to add this to your notes just to make sure that you remember that. No brackets in intervals of increase or decrease. Because then we would be including the point where it's actually changing. All right, now a new idea, which is actually very simple. That's the idea of maximum and minimum. Maximum, and listen very carefully, it's the highest point on the graph. The highest point on the graph. Since we're talking about a point, then we would write maximum and minimum as an ordered pair. Well, if you look at the graph, the highest point on the graph happens to be at that point right there. And that point, as an ordered pair, is -1, 2. So that would be the maximum. There also is a low point on the graph, which happens to be right there. And that point on the graph, as an ordered pair, is 2, -7, right? Okay? And so we always write our maximum and our minimum as an ordered pair. Now there will come a time where there may not be a maximum, or there may not be a minimum, or there may be multiple maximum or minimums. Okay? All right, so maximum, minimum, that idea should seem pretty simple. And now the part where for some people may be a little confusing, so you need to make sure that you're really paying attention. And that's the idea of domain and range. Now I'm going to go backwards for a second. So the only place that we have talked about domain and range is in terms of ordered pairs, right? Back when we talked about it about 5 or 6 lessons ago, when we're talking about domain, we're talking about the x values or the input values. When we're talking about range, we're talking about the y values or the output values. And so we've done this with ordered pairs, where the domain is the listing of all of the first numbers in the ordered pairs, and the range is the listing of all the second numbers in those ordered pairs. Now we could also take a bunch of ordered pairs and we could graph them and find the domain and range. But that's still simple, because the domain would be the first number in each of those 5 ordered pairs, and the range would be the second number in all 5 of those ordered pairs. But what in the world are you going to do when you have a graph like this? Because, yes, there's a point here and a point here, but there's also a point here and 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 here, and an infinite number of ordered pairs in between those. So how in the world do you then write domain and range? Well, the easiest way to do it from a graph is to sort of scan the graph and look at the graph very carefully. So when we're talking about domain, once again, we are talking about the x values. And since the x values always go from left to right, or think about the x-axis, left to right, you're scanning the graph from the left side of the graph, to the right side of the graph. And you're trying to make sure of all the values that are between the beginning of the graph and the end of the graph. So I'm scanning from left to right, and that graph is everywhere in between those 2 points. It's everywhere in between those 2 points. If I take that off there, I could also just draw. It's everywhere from this point to this point. So that means that the domain would be from, going left to right, from -3 to +7. Now we are in the domain of range. We can use brackets or parentheses. And so therefore I have brackets because we are actually including the points there. All right, so now let's talk about the range. Remember the range, we're talking about y values. Y direction is up or down direction because that's the direction of the axes. So we're scanning the graph again, but we're scanning up and down. So the low point on the graph is here. The high point on the graph is there. So is the graph covered everywhere between here and here? And the answer to that would be yes, because this is a low point and that's the high point. So the low point on the graph and the high point on the graph is there, so therefore the range would be from -2 to +7. And there is a point at every part within that range. So another way of thinking about it might be this. Are there ordered pairs? I meant to pick a different colored pen. Are there ordered pairs everywhere from -3 to 7 if you're talking about those being the x values? In other words, is there an ordered pair somewhere on that graph that is -3 comma something? Yes or no? -2 comma something? -1 comma something? 0 comma something? 6 comma something? 5 comma something? 4.2 comma something? Okay, let's flip it now to the range. Is there an ordered pair that is something comma -7? Something comma -6? Something comma 0? Something comma 3? No. That's why 3 is not included in the range. It's everything in between -7 and +2. Okay? So like I said a few minutes ago, domain of range will be the toughest thing for some people, but if you scan the graph, it's not that bad. Okay? Now, when we're using domain of range, depending on what the graph looks like, we can use brackets and sometimes parentheses. Okay, depends on what we're dealing with. Okay. All right, everybody take a look at number 2. I would want you to turn to your shoulder partner and try and do the intervals of increase and decrease, the max and min, and the domain of range. Go ahead, I'll give you a few minutes. Because this is the first time that we've looked at a graph like this. You have to assume that if the graph looks like this, that it does continue on in that direction, and it does continue on in that direction. In other words, notice that the graph on the left side is going in the downward direction, but it also is very slowly going to the left. Let me exaggerate it. It's going in the downward direction and still going to the left. Whereas on the right-hand side of the graph, it's clearly going up, but it's also going to the right. So it's going up and to the right infinitely. It's going down and to the left infinitely. And you have to think about that in some of these things. All right, go back to doing this with your shoulder partner. All right, so this one is a little bit different than the previous one. And the reason is because the graph goes infinitely to the left and downward on the left-hand side, and it goes infinitely to the right and up on the right-hand side of the graph. Okay? So, yes, that's what it's doing on this side, but it is increasing from there to that point right there. So I think it's clear as far as that part of the increase, it is going from something to, what is that, -3. But what's this part of that interval? It's negative infinity, right? The graph just keeps going on and on and on. And then the other part of the increase over here is from 2 to something, and that graph just keeps going on. So what is this part of that interval? Positive infinity, right. So let me take that off of there. So it is increasing from negative infinity to -3, and then also from 2 to infinity And since we have two intervals there, we're going to connect them with the union symbol. And then clearly this thing is decreasing from here to here. So from -3 to +2 right there. Okay, so that's the intervals of increase and decrease. Now, maximum and minimum. This confused a few people, and you've never seen something like this before, so that's totally natural. By the way, there is no constant interval there. And remember, don't use brackets in intervals of increase or decrease. So some of you thought that, well, since the graph goes on infinitely this way, that the maximum must be infinity. Well, that doesn't really make any sense, by the way. So anytime you have a graph that goes infinitely in both directions, we usually refer to the maximum and minimum as relative maximum and minimum. In other words, relative to the fact that the graph on left and right side go either to infinity or negative infinity. So what we have to do then is we have to focus on the other parts, ignoring the to infinity and a negative infinity part, and focus on these points right here. So that means that there is a maximum. It's a relative maximum, and the relative maximum is at the ordered pair -3, 8. And the relative minimum is at 2, 3. Okay? Now the domain and range. Anybody want to take a shot at the domain? Come on, some of you have it.
Negative infinity, infinity.
Yeah, it's negative infinity to infinity. Because look, the graph, remember, this graph keeps going in the downward direction, but also slowly to the left. It just keeps going to the left. Because if we're talking about domain, we're talking about left to right movement. And on the right-hand side, it is going up, but it's also going to the right infinitely as well. So it never stops. So therefore, the domain is from negative infinity to positive infinity. How about the range? How about the range? Same thing exactly, right? Because the graph goes downward forever and ever and ever, and upward forever and ever and ever. And range means we are focusing on the up and down movement, the y movement, so negative infinity to positive infinity. All right, turn the page. Between you and your shoulder partner, please find the intervals of increase and decrease, max and min, and the domain and range, and I'll get back to you in a few minutes. So the intervals of increase and decrease. It is increasing from here to here, and from here to here, and from there to there. Therefore, there should be 3 intervals of increase. And then as far as the decrease goes, let me try and change colors here, if I can. I don't think that's working out very well, so I'm going to go back to this. And then here's one interval of decrease, and then there's another interval of decrease. So therefore, it is increasing from -10 to -7, and then from -6 to -2, and then from 7 to 12, and decrease from -13 to 10, and then from -2 to +5. Okay? Maximum and minimum. And by the way, there is no constant interval there. All right, maximum and minimum. Well, I can see there is a high point on that graph right there, and 2 low points that actually happen to be at the same value there. So therefore, the maximum is at -7, 8. That is an ordered pair. And then there are 2 minimums, and typically, since they're just ordered pairs, we would separate them with commas. So -6, 1 as one minimum, and then another one at 5, 1. Yes?
But if it was just a straight line, just a straight line, what would the maximum and minimum be?
Are you talking
Like
about?
horizontal.
Are you talking about just like a linear, like this?
No, horizontal line.
Horizontal line, like this?
Yeah.
Well, there would be no minimum or maximum, because there's not a specific point. There's just a whole bunch of them there, right? Okay. All right, so now domain and range. Well, domain is talking about all the x values. What I saw some of you do, not a lot, but some, you went, all right, well, that graph starts at negative 13 and ends at 12. And my comment to that is, no, it doesn't.
It's negative 13, comma 7, negative 6, comma 5, and 7, comma 12.
Okay.
With brackets.
Okay, so basically, yeah, the graph is going from here to here, and then from here to here, and then from here to here. There are no values in here, right? There is no ordered pair that is negative 6.5 comma something. There's no graph in there. And there's also no graph in here. There is no ordered pair that is 6 comma something. There's nothing in there. So therefore, as far as the rate or the domain goes, we're going to have several intervals. From negative 13 to negative 7 with brackets, because we are including the endpoints. We're just measuring the domain there. And then from negative 6 to positive 5, because there was nothing in terms of the graph going from left to right in between negative 7 and negative 6. And then the last interval is from 7 to 12. So you have to be cognizant of kind of holes in the graph. And then the range would be from 1 to 4 and from 5 to 8. And the reason is because right in here, going from the bottom of the graph to the top, there are no ordered pairs that are found in that little slice right there from 4 to 5. In other words, there are ordered pairs that are something comma 1, something comma 2, something comma 3.1, but nothing that's like 0 or something comma 4.5. But there are ordered pairs that are something comma 5, something comma 6, something comma 6.2, something comma 7, something comma 8, and so on. Okay? So we have to be careful on the domain and range. All right, so because of time, we're going to skip number 4, and I'm going to have you do number 5. So do, just like with the previous ones, turn to your shoulder partner and come up with all the parts for number 5. Go ahead. So intervals of increase. Well, this nonlinear graph is increasing from here to here, and then from here to there. So therefore, that would be from 3 to 6, and then from 6 to 10. It is decreasing from here to here, and then from here to here. And so that would be, and we're scanning from left to right, so we're using x values when we're doing this. It's decreasing from 0 to 3, and then from 10 to 13. Okay? Remember, you're focusing on the x values in those intervals because you're going from left to right, the same way that you read. All right, and there is, once again, no interval that is constant. Maximum and minimum. Well, the maximum, the highest point on the graph is right here at that order pair, and then the lowest point actually happens to be right there, which we will end up calling that the vertex of the parabola part of that graph a little bit later in the year. And so the maximum is at the ordered pair 10, 11, and the low point is at the vertex of the parabola part at 3, 1. So that should not have been too bad. It's the domain and range, once again, that can cause some issues. So domain, we're talking about x values. And so there were some people who thought that the domain was this. 0 to 13. By the way, that is not correct. Why is that not correct? Fritz?
Because at 5, 10, 6, 10, the circle is open.
Yeah, there's a hole right there in that graph. If we thought about it in terms of ordered pairs, yes, there is an ordered pair on that graph that is 0, comma something. I'm referring to 0 because domain refers to x values. There is a 0, comma something. There is a 1, comma something. There is a 5, comma something. There is not an ordered pair on that graph that is 6 comma something. So therefore, there is a break in the domain there. So therefore, the domain is from 0 to 6, including 0, but not including 6 because of the hole in the graph. And this is the second time that we've come across graphs with holes in them. And then from 6 to 13, going from left to right, not including 6. And then the range is a little more straightforward. It is from 1 to 11, scanning the graph from the bottom to the top. Now, but I have one last question for you. Why, when we're scanning the graph from the bottom to the top, did that not come in to play there, that hole? Why not? There was already a point there, right? This one sort of takes care of it when we're going up from the bottom to the top. Or there's another one right there that sort of fill that in. Okay? All right, we are finished. You know where the assignment is. Go ahead and get